Okay, so I'm going to solve problem number 3. And again, the first thing you do is you make these and you determine what is required. Find the tensions in the two ropes. Okay, and they've already been labeled. So it's T1 and T2. And you write that here. T1 in newtons. And B is T2, also in newtons. Okay, so that's important that you know what you're solving for. Okay, and so we have to show those vectors here. And you can make it an arrow, and tension is going away, and you can use the whole thing so it's out of the way. And then also here, all the way there, it doesn't matter how big you make this, not drawn to scale. Okay? Now what's missing here is the weight of the boy. And that's what students always forget, that there's always an FG or W, and that is 90 newtons. That's given, right? Circle that and call that either FG or W, whichever you like. Okay, and now we have to make a free body diagram. And I recommend that you don't necessarily make it to scale, you overemphasize so that you have a clear perspective, meaning that the angles are wider, right? So here, going down, FG, correct? Then going this way, I'm going to make it wider so that it'll be easier for me to see. Okay? This is your T1. Okay, and this angle here is 5 degrees. Okay? And then here, this is T2. And this angle here is 10 degrees. Okay, so we have to resolve these because they're diagonal. There's actually one vector here called T1y, correct? And there's another vector here, and this is called T1x. Okay, so we don't think about that anymore, just these two. And then here we have T2y and T2x. Okay, I like that in the bottom, so we'll put that here. T1x. So, and we don't think about that. So instead of having 3, we've resolved these two. Now we have 5. We have 1 going this way, 2 going that way, 3 is the gravity going down, and going up we have T2y and, oh sorry, this is 1. This is 2. Okay, can't make that mistake right off. Okay, so 1, 2, 3, 4, 5. Okay, so we start the solution with the summation of forces along the x is equal to 0. And what does it mean? The forces going to the right are equal to the force going, the right is equal to left, and we only have one of each. So T1x is equal to T2x. Okay? And we're going to substitute that for this. So when you use it, I recommend that you put it in a box so you won't go back to it. You only use these once. So instead, we're going to use T1 cosine of 10 degrees. Okay, is equal to this second one here, T2 cosine of 5 degrees. Okay, then we'll solve, since both of these are unknown, you have to solve T1 in terms of T2, and so it's T2 times this one, which is the numerator, 5 degrees, and then this one becomes the denominator over here, so you put that cosine of 10 degrees. Okay, so this, you put a box on that, and you label it equation 1. Okay, you need 2 equations to solve this problem. Your second one is going to come from here. Summation of forces along the y is equal to 0. What does that mean? What are the forces? You have gravity going down here, and going up is T2y and T1y. So we're going to write that. T2y plus T1y is equal to Fg. Okay, then we're going to substitute it with these values here. First, T2, which is this one. So T2 sine of 5 degrees plus, I'm going to put a parenthesis on that, T1, so we did this, we're doing this one now. And what is it? T1 sine of 10 degrees. Okay, is equal to Fg. Okay, now what we have here is this in terms of that, so we're going to substitute. Instead of using this, we're going to put the whole thing in there. Okay, and so copy this part, T2 sine 5 degrees plus, instead of T1, you write this whole thing, T2 cosine of 5 degrees cosine of 10 degrees, close parenthesis, right? And then that's just this, and then we have to put this here, sine of 10 degrees is equal to Fg. Okay, now here's the hard part. You have to remove this, so you put a big bracket here, and then you have T2 equals, copy the rest, sine 5 degrees plus, that's already outside, right? Put that out. So you copy the rest, cosine 5 degrees, 5 degrees, cosine 10 degrees, sine 10 degrees is equal to Fg. Okay. Hi. You can either get this whole number now, but eventually what you're going to get, you have to move, this is the coefficient of T2, and that's what we're looking for, T2. And so what you're going to do is move this to the denominator, so transition T2 is equal to Fg. Then under that, you write all of this, sine 5 degrees plus cosine 5 degrees cosine 10 degrees sine 10 degrees. Okay, that whole thing, and then this is the numerator. And believe it or not, those are all numbers. I'm going to try to do it for you here. Look at this. You start here, right? Or you can start there. So 5 degrees, 5 sine, right, plus parenthesis, it's 5 degrees cosine divided by 10 degrees cosine times 5 sine, then close parenthesis, equals. Okay, you have that. That's that whole thing there. You store it in memory, and then what is your, this weight is actually 90 newtons. Okay, so clear. 90 divided by what you had in memory. The answer is too big. Yikes.